Hey guys! So today we're going to be talking about polynomial division using the box method. So before we get started, I wanted to re-go over the general box method and what that means, what it looks like. So when I'm talking about box method, I'm talking about using generic rectangles, or in other words, area models, to help us model this sort of problem. Typically, when we see these generic rectangle problems, we are using multiplication because in order to find the area of a rectangle, we have to multiply the length times the width. So if we're given two polynomials, we can set up a generic rectangle so that we can multiply the length by the width to figure out the area of the entire rectangle when we add it up together. So now using this model can help us with division because multiplication and division are inverse operations of each other. So in basic math terms, I could say that 3 times 2 equals 6, and how division can be related into this is because 6 divided by 3 equals 2, or 6 divided by 2 equals 3. So I could get all of these terms if I am missing some part or piece of my entire problem. So let's look at how we can use one of these models to help us divide polynomials. So the polynomials we will want to be dividing is 2x cubed minus x squared minus 24x minus 16, that whole quantity divided by x minus 4. So let's go ahead and set up our polynomial division using the box method. So I know if I set up using some sort of multiplication, I have some polynomial up here that if I multiply it by x minus 4, I am going to get the answer of 2x cubed minus x squared minus 24x minus 16. So now I need to figure out how these terms are going to fit into my box. Because my first term is 2x cubed, I know that that will be the only term in the top corner of my box. So now I just need to ask myself, what times x would give me the value 2x cubed? And that would be 2x squared. So now I can multiply my 2x squared by the negative 4 to fill in my bottom left box. And that will give me a negative 8x squared. So now I'm going to be moving on to my next term, which is negative x squared. In my generic rectangle, I already have a negative 8x squared. So in order to get to a negative x squared, I have to add positive 7x squared, since 7x squared minus 8x squared will give me the negative 1x squared. And so now I just repeat the process. I have to ask myself, what times x is going to give me 7x squared? And that will be a 7x. And now I can multiply 7x times negative 4 to give me a negative 28x. And then I follow in suit. So I go to the next term, which is negative 24x. And I look in my generic rectangle, I already have negative 28x. So I need to add positive 4x to get my negative 24x term. So once again, I ask myself, what do I multiply x by to get 4x? And that is 4. And then I can multiply 4 times negative 4, which is going to give me negative 16. I'm in the wrong color again. Negative 16. And now I look at my equation. I have negative 16, so my problem is finished. Sometimes with these problems, you can keep extending your box. Sometimes you don't need your box to go as far. It just kind of depends with how many terms you are working with. So our final answer to this problem is going to be what is in the highlighted section up here. So we were asked, what is 2x cubed minus x squared minus 24x minus 16 divided by x minus 4? And the answer is going to be 2x squared plus 7x plus 4. And the reason behind that is because 2x squared plus 7x plus 4 times x minus 4 is going to give me that 2x cubed minus x squared minus 24x minus 16. So for this problem, this is our final answer. So this problem worked out really, really nicely for us because it divided evenly. So let's take a look at another problem that might not divide evenly into something where we have a remainder or something left over that we have to deal with. So for this next problem, we have n cubed minus 5n squared minus 23n plus 12 all divided by n plus 3. So I've already started setting up the generic rectangle. So we have our n plus 3 on the side. We are trying to figure out what multiplies to n plus 3 to give us n cubed minus 5n squared minus 23n plus 12. So once again, we start with our first term. We are going to put this term in the top corner of our box since that is kind of going to be a lonesome term. So we have to ask ourselves what times n gives us n cubed, and that is n squared. And then we can multiply the parts of our box that we already know. So n squared times 3 is going to give us a 3n squared. Then we move on to the next term in our problem, this negative 5n squared. It is really, really important that we do look for negatives, so make sure you are doing that. So we have a positive 3n squared in our generic rectangle already. So we are going to have to subtract 8n squared to get to that negative 5n squared value. So we multiply negative 8n by n to get our negative 8n squared. And then we can multiply our negative 8n by 3 to get negative 24n in our box. We can extend our box. I didn't extend it far enough for this problem, but that is okay. You can always continue to extend your box out. So we'll move on to the next term. We have negative 23n in our generic rectangle. We already have negative 24n, so I just need a positive n to get us to that negative 23n. N times a positive 1 would give us to the single n. So then 3 times 1 would get us to 3. However, we have a problem here because in our generic rectangle we have 3. However, we needed to get up to 12. So in order to make this problem work, I have to add 9 units onto the end of my generic rectangle to make the math add up to that plus 12. Because I have 9 extra tiles I need to account for. So when we write out our answer, we're going to write what is in this highlighted section since that's really what we were solving for. So our final answer would be n squared minus 8n plus 1, but we have to deal with our remainder of 9. Now we have two different ways to write this remainder. We could write it as a remainder of 9, or I could add 9 over my m plus 3 quantity. So those are two different ways to account for the remainder. Remember, it's a remainder because it was not actually divisible by our divider, our denominator. So we could not divide 9 any further by the n plus 3. So if you want to write it as a remainder, you can write it one of two ways, with it being denoted as a remainder or adding that final part that we could not divide out. So two options for that, but that is how we divide polynomials using the generic rectangle method. The nice thing with this is we've been dividing by binomials, which is 2 terms. You could divide by any type of polynomial. Your box would just have some different dimensions. So you might have 3 terms down on your box instead of just 2. But just know this is a foolproof way to divide any polynomials.